Hello, grade 10 math students. So in the last lesson for this week, we're going to talk about solving systems of linear equations by using something called elimination. And one of the key parts of elimination is this idea that whenever we are adding or subtracting large things, and you guys have been doing this for a while, if we stack them on top of each other like this, oops, not like that, ignore that, like this, then it becomes easier, right? So if I had to do 2,968 plus 1,748 and I was adding them side by side, that would be hard. But as soon as they're up and down, now I can do that. So for instance, I know that 8 plus 8 is 16, so I can write my 6 here, carry the 1. 6 plus 4 is 10, plus 1 is 11, carry the 1. That's 17, carry the 1, that's 400, so 4,716, right? And so this is an idea that we've kind of learned about. And we see the same thing happening when we subtract. So for instance, it's way easier to subtract when things are stacked than if they're not. So 9 minus 6, that's 3, that's really easy. 4 minus 1, that's 3. 6 minus 5 is 1, 7 minus 3 is 4. So that's way easier, an easier way of doing this instead of going like this, right? This would be a lot harder. So the same happens for polynomials. So remember, polynomials are just things with letters in them. And so one way that we've been learning to collect like terms is to gather them like this. So we would gather our like terms. We do 3x plus 2x, then 2y minus 5y. But we can actually stack them. So we can write the first bracket on top, just like this, followed by the second bracket right underneath it, okay? And so this allows us, as long as our letters are lined up, that we can easily see what we have to do. So I can do 2 minus 5, well, that's going to be negative 3 y's, and 3 plus 2, well, now that's 5 x's. Okay, and that's an easier way that maybe I can add and subtract polynomials. So this is kind of what's happening here. This is what today's lesson is going to be. We are going to, instead of solving by substitution, because like we saw in yesterday's lesson or the previous lesson, substitution doesn't really work if it's going to get super complicated. So here, what we can do is we can actually use elimination. So we can add or subtract the two equations together so that we can get a letter by itself. The key parts to this, though, and it's super important that we do this, is that we want to stack the x's on top of each of the y's. Okay, so we're stacking, sorry, that came out wrong. We're stacking the x's on top of each other and the y's on top of each other. So you don't want x's and y's right on top of each other. You want them so that the same letter is on top of each other. They essentially want to line up. Okay. So let's look at a couple of examples. Subtraction can be tricky because we need to remember that we are subtracting each term. So here in this first one, I have 4x minus 7y, subtract 3x minus 2y. And I'm going to start this by stacking. So I write my first bracket on top, 4x minus 7. My second bracket underneath, 3x minus 2y. And then whatever sign was in between them, that's the sign that goes out front, okay? So I'm going to start, and I'm going to use green here. Sorry, thought it was on the highlighter. Green here to show my y's. So I'm going to do negative 7 subtract negative 2. And I notice here that there's a negative and a negative. Well, that's the same thing as having a positive here. So this is the same thing as saying negative 7 plus 2. That's going to end up being negative 5y. Okay? And now I'm going to look at my x's. So now I switch over to my x's. I have 4x's minus 3x's. That's going to be 1x. Or x minus 5y. Both of those are okay to write. So we're almost done today's lesson. It's super short. And then you're going to try the examples here. So we're going to do the exact same thing in this example. So right now I have negative 5x plus 3y minus negative 2x plus 8y. And I'm going to start by stacking. So I'm going to write my first equation on top. So that's negative 5x plus 3y. And then my second bracket on the bottom, negative 2x plus 8y. And the sign that's out front is the sign that's in between the two brackets. So in this case, it was subtract. And I'm going to draw my equal sign. I'm going to gather my like terms. So I'm going to look at my y's first. So I've highlighted those green. Okay. So I have 3y minus 8y. So 3 minus 8, that's negative 5. My y comes along for the ride. And then I have negative 5x subtract negative 2. And my two negatives really make this into a positive. So this is the same thing as saying negative 5x plus 2. So negative 5 plus 2, that's going to be negative 3x's. Okay, so really this equals negative 3x minus 5y, right? So that's kind of gathering these like terms. So I want you to try the next two on your own. I have put the completed notes on our Google Classroom. And now let's talk about this question. So you can just pause it and do those on your own and then resume. I want you guys to think, how would we make the following things equal to 0? Would you add or subtract the terms together? So if I had 3x and 3x, how would I make this go to 0? Specifically, would you add or subtract these? So if I were to add 3x and 3x, would I get 0? No, I would get 6x. But what happens if I subtract them? Okay, well, if I subtract them, then I do get 0. So here I would subtract them. What about the next one? If I have negative 5y and positive 5y, if I subtract them, do I get 0? So if I were to subtract them here, like this, negative 5y subtract 5y actually gives me negative 10. So that's not going to give me 0. So what happens if I add them? Negative 5y plus 5y, that's 0. Okay, so I'm going to add them here. Okay, 12x subtract 12x, or sorry, 12x and negative 12x. If I were to add those together, I'm going to get 0. And negative 100y and negative 100y, this should be a negative, or sorry, a y there. If I were to add these together, negative 100 plus negative 100 is going to give me negative 200. But now if I subtract them, negative 100 subtract 100, these two subtracts make a positive. It's like adding, that's going to go to 0. So I have to subtract. Okay. Essentially, there's a couple of rules here. So to make a term go to 0, we need to understand that if the signs are opposite, then we always add. If the signs are the same, then we subtract. So if our signs match, we're going to subtract. If our signs are different, we're going to add them. So let's use this idea for this one question here. And then you guys can work on your own problems, and this finishes off the week nicely. So I'm going to look at my two equations, and the whole idea here again is that I want to add or subtract my equations together so that I can get one of my letters to go to 0. And the first step is to decide which variable we're going to get rid of. And you do this based on whether or not you can match them. So here are my coefficients, those numbers in front of my letters the same. So if I look at my x's, I have a 4 and a 4. So that's good. Those are matching. I can get rid of those. If I look at my y's, I have a 5 and a 3. Not matching. So I'm not going to get rid of my y's here. My goal is going to be to get rid of my x. Okay, so goal equals eliminate x. Okay, so if I'm looking at here, I have 4x and negative 4x. So this is a positive. My first one's positive. My second one's negative. So they're opposite. And we said that whenever they're opposite, we're going to subtract my equations to get together. Okay, so we are going to, or sorry, whenever they're opposite, we're going to add them together. So we're going to add my equations, add because opposite signs. And so if I add them together, this is what's going to happen. So I have 4x minus 5y equals 7, negative 4x plus 3y plus negative 5. So if I add these together, my x's go to 0, negative 5y plus 3y, that's negative 2y, 7 plus negative 5 is 2. Okay, so when I add these together, remember, undo. Remember, I'm going to line up my columns with my different colors just so that you can see them and how this is working. We're adding up and down here, okay? So what I'm left with is this equation that I get negative 2y equal to 2, okay? I need to now solve for this. So if this is my equation, I'm going to solve for it. So if I'm looking at negative 2y equal to 2, what's happening between my negative 2 and my y? That's multiplication. How do I undo multiplication? I'm going to divide both sides by negative 2. My negative 2's on my left-hand side cancel out and leave me with y. 2 divided by negative 2, that's negative 1. Okay, so I get y equals negative 1. That's my first solution. My second solution, just like we were doing in our previous lesson, we're going to substitute the value that we found for y back into one of the equations. So I'm going to sub y equals negative 1 into my first equation. Okay, so every time I see a y, I'm going to replace it with a negative 1. So I have 4x minus 5, and instead of y, I'm going to write negative 1 equals 7. So I get 4x here. Negative 5 times negative 1, that's positive 5, equals 7. And now I'm going to rearrange so that I can get x by itself. If I'm adding 5 on the left-hand side, I have to subtract it to get rid of it. 7 minus 5 is 2. Okay. And then my very last step, what's happening between that 4 and the x? Well, that's multiplication. How do I undo that? I'm going to divide. So I'm going to divide both sides by 4. My 4's cancel out. And 2 divided by 4, well, that's 1/2 or 0.5. Okay. So my point of intersection here is going to be my x first, which is 1/2, and then my y, which was negative 1. Okay, so this is my POI. And again, we can check to see if this is right. So if I'm looking at here, I'm going to check to see if this is right. My equation for my first check is going to be 4x minus 5y equals 7. And I'm going to end up subbing y equals negative 1, x equals 1/2 into my equation here. So on my left-hand side in this equation, I have 4x minus 5y. On my right-hand side, I just have 7. I'm going to leave that here. So the goal is to see if I were to put this y and x value into my equation, will I get 7 as an answer at the end of it? So let's see here. So 4, and instead of x, I'm going to replace it with 0.5 minus 5, and instead of y, I'm going to replace it with not 7, negative 1. Okay. So 4 times 0.5, that's going to give me a 2. Negative 5 times negative 1, that's a positive 5. All of this equals 7. So my right and my left-hand side equal each other. This means that this is a valid solution. This works out because we know 7 does equal 7. So again, I'm going to try it with my second equation, and my second equation in this system was negative 4x, and I'm getting these from the top of the page. Negative 4x plus 3y equals negative 5, and I'm going to substitute the same things into here. So on my left-hand side, I have negative 4x plus 3y. My right-hand side is negative 5, so now my hope is that my left-hand side is going to equal negative 5. So I'm going to substitute x is 0.5, so instead of an x, that's what I'm going to write there. And y is negative 1. Negative 4 times 0.5, well, that's going to equal negative 2. 3 times negative 1 is negative 3. Negative 2 subtract 3, that's negative 5. So my left-hand side does equal my right-hand side. Okay, so math smiley face here. Okay, so there's one more example that I have typed up and laid out like this. I want you guys to actually try this one. And at the end, you should get an answer of a point of intersection of negative, I've already done it. So it should be negative 2 and 3. Let me know if you don't get that, if you need me to continue this video. But we're sitting just over 15 minutes, so I think that you've been listening to my wonderful voice enough. I hope that you guys are having an awesome time. I miss you all very dearly. I cannot wait to see you again. But yeah, so this kind of concludes week 3. Keep a lookout for that assignment. Like I said, it should be posted fairly soon. And I'm hoping that you guys are kind of okay with this. Don't forget that you can add questions to that Google Doc and I'll be watching for them. Have an awesome day.